Yeah, so unit testing is a pretty important part of the development process. Testing is normally a part of your development process, I expect, where you click through test or otherwise manually test systems. So unit testing is a way to automate that. And so today I'm going to be talking about why you might want a unit test. I'm not going to go into the details and the nitty-gritties of how to actually do testing, but I'm going to talk about how to test things that are hard to test, and then ways you can set up processes to keep your testing current and always have them running. So we're going to call that continuous integration. So yeah, I felt like I needed to introduce myself, but I felt like I've met everybody in the room. I'm an art college student. I got into programming because I needed money. I got into Cake because I needed to get street cred. So I've been working on Cake for 2.5 years now. I've developed several plugins, including Debug Kit, the API generator, and I have a whole bunch of other plugins on my GitHub account. And my day job, I work at FreshBooks. We do invoicing and online billing as a service, and I'm the lead front-end developer there. Can unit testing make me awesome? Hell yes. So why would you even bother writing tests? Like, it seems like a lot of extra work. You write code to make sure your other code works, but how do you make sure, like, why bother? Why waste the time to do it? It's going to take more time. It's going to cost you more money. The main reason is it helps you reduce the amount of time you spend fixing problems later. And it helps you ensure that things work, and when you change things, that everything that used to work still works. How many of you have ever made a change and broke something that used to work? Yeah. So as you break things, you write tests for them, then you'll never break the same thing twice, which is one of the big advantages of unit testing. Even if you have an old code base, as you come across bugs, you can write tests, and then you won't ever have those same bugs again in the exact same way you had them before. Unit tests are also really helpful because if you write tests as you're writing the code, they help you design complicated or difficult to plan out pieces. And if you have a ticket that says, like, say you're working at your job and you have a ticket that says, build a CMS. Awesome. That's so easy to do. So what you can do is you break it down into tests and then write it one test at a time. And then as the tests pass, you'll have something that works. It also creates living documentation. If you want to know how the code works, you can look at the tests. If you ever forget what the code is possible of doing, what the edge cases are, you can look at the tests. It helps you catch issues earlier. I don't know the number, I couldn't even count the number of times I've written tests for things and then found out a crazy bug. I'm like, I wonder what happens if I put some garbage input into it. Oh, it breaks. Well, some user will do that because, as we all know, users are wonderful people. It increases your confidence about your code. When your boss comes by and is like, will it work? You can say, most certainly. Everything that I've written tests for works. So everything that I know about works. You can't do that without automated tests. You can say, well, I've spent 3 hours clicking through it. And your boss is like, so does it work? And you're like, well, I guess. It works for me. And you have automated killer robots. I love killer robots, especially when they're automated. The best thing about automated tests is they're automated. You can put them into things like continuous integration. They're run faster. You can write tests that can test all kinds of things that would take you many hours to click through tests. And then every time you make a change, you would have to click through that same 5 hours of work. Now you don't have to do that. You click a button, it runs everything it knows about, it tells you you suck and you broke something, or you're awesome and everything still works. So of all the things you could test, what things should you test? Code that keeps you up at night. Everyone has code that scares the living pants out of them. Write tests for it. It will be less scary. Code that involves real money. If your application or your job involves taking people's money, write tests for that. Because people get really pissed when you lose their money. And you'll get pissed when you don't get money. Code that's broken before. If you have code that's fragile, write tests for it. That'll help you at least feel a little bit more confident that it's not going to just blow up in your face. Code that it's hard to test manually. I have some code that generates PDFs. Generating PDFs is a long process sometimes. If I can write tests that can make sure that the parts that are going to work, I can take a PDF that I know is supposed to come out, compare it to a PDF that's come out, and I can compare the two, then that works really well. There's different flavors of testing. There's unit tests and there's functional or integrational tests. The two have two different kind of scopes and are used for different purposes. So unit tests test the smallest parts of your application in isolation. So you want to test basically at the model, at the method or object level. So you want to test, like, if I call this method, does it return true? If I call this method, does it return an array? Does it return what I think it's going to do when I give it the various types of inputs that I'm going to give it? Generally, you end up using mocks for this. I'm going to talk about mocks because mocks are really helpful for testing things that are hard to test. And unit tests are extremely useful when you do test-driven development. I remember someone else asked a question about that, and there weren't a lot of hands. So test-driven development is kind of you write the tests before you write the code. Or you write them in parallel. So you write a test, write some code, write a test, and keep going like that. And then the mantra, the high-end goal of test-driven development is that you never write a line of production code without having a failing test. Sometimes that's hard to do in a real job. So I usually go for write some code, write some tests, and delete code until no tests break. And then keep adding the code back in until it passes. Functional tests. Functional tests test things that working together. So you basically test the top-level object and ensure that all of its guts are working together. So some examples of doing functional testing would be like testing models in Cake. So oftentimes you have to load a fixture, and that's automatically an integration test because you're testing not only the model, which is your logic, you're testing the database objects which talk to the database, you're testing the data in the database, and you're testing the whole system back to front. Functional tests are often a little bit slower because they're using a lot more resources. They're testing all the way down to the database. They're testing all the way back up from the database. They're testing all the way out to a remote service and back. Unit tests basically test one class. You're just testing a little tiny piece, checking its return, and then you check all the little tiny pieces, and then those are your unit tests, and then you put them together into integration tests. Some of the challenges of testing, there are a few. I'm just going to get a drink of water. Am I going too fast for anybody? No? Okay, good. So the biggest challenge for testing is time. It takes time to write tests, but it takes more time to fix them later. And fixing the same bug twice takes more time than it does to write one test and not have to deal with that bug again. The other problem with tests is it only shows the presence of errors. It doesn't show the absence of errors. Just because you write one test doesn't mean your code is bug-free. It just means the one thing that you tested doesn't have bugs, or does what you think it does. And unit tests can only catch errors that you have tests for. So if there's some sort of case that your tests have not taken account of, you won't catch that with your automated testing because the computer can only do what you've told it to do. And sometimes it doesn't even do that. But yeah, you can only catch errors that you know about. So as you find errors, you add them into the test suite, and then those become known parameters of the system. The benefits of testing, once you get past that hurdle of time and the little bit of extra initial costs, you find problems earlier. You can find problems before your QA person gets anywhere near them, or if you don't have a QA person, before your boss starts clicking through things and starts wondering why shit's broken. You can automate this process. Automation is amazing. We're programmers. We like making things simple. We like making things automatic. That's why we use frameworks, to make things automatic. Test makes more things automatic. It's awesome. There's less manual testing. Unit testing can be extended into like an integration test. You can write Selenium scripts, and you can have console commands that run Selenium test, which is like a browser click-through test, onto a virtual server, which is a really amazing thing. It's easy to ensure that your requirements are met. When someone gives you a set of requirements, you can convert those into tests, make them all pass, and then you know your requirements have been met because they've been converted into tests and they're all passing. So you're done. The end of the part where I extol the wind sauce that tests can bring, of which there is. Mock objects. So throughout your trials and unit testing, you'll come across things that are really hard to test. And mock objects are a really useful way to allow you to test things that are really hard to test. So I'll get into what those are. Writing tests is hard. Isolated tests are also hard. Oftentimes we end up writing integration tests, and integration tests can often be more fragile than a unit test. Mocks help you make sure that your objects are touching each other the right way. If your objects start touching each other the wrong ways, then the tests using mocks will start to fail. Tests also help you mock out behavior before you actually implement it. So if you know this class has to talk to this other class that's going to talk to some service, and you know it's going to have some sort of a post method, but you're not really sure what it's going to do, and you need it to return an array, you can use a mock and say, I have no idea what this piece is going to be. My friend Joe is going to write it. So I'm just going to put a mock here. It's going to return an array when I pass in a 2. And my object's going to pass in a 2, and it's going to get back an array. And whatever happens over here is Joe's problem. When Joe's finished, we can make sure that on his unit test, I can put in a 2, and I get back an array. And then I don't even need to know what Joe's class does. It's just, who cares? Can I use a mock for global functions? For stuff not in functions. Let's say you just have a file you include, and it just runs in global scope. No. You have to have functions, and they have to be in classes. And they have to be instance methods in order to mock them. So if you have a whole bunch of static methods, you cannot mock them. When to use mocks. Mocks are best used when you're having to talk to things that are either far away, expensive, or dangerous. Sending things like email. If every time you run your automated test suite, it emails all your customers, yeah, bad things are going to happen. Also, talking to email can be expensive. You have to boot up an SMTP server. That means your test environment has to have access to SMTP or a mail server or send mail. Those are external dependencies that you don't really want your test suite to have. Talking to web services, Twitter, PayPal, YouTube, Google Maps, all those things. Those are perfect places to use mocks because then your unit test, if your test suite is running along, oh crap, now I got to talk to Twitter. Oh crap, Twitter's down. Test fails. Did the test fail because my code's broken or because Twitter's down? Like, it is every 5 minutes. So that's a perfect place to use a mock. Then your test will just keep going. It'll be like, oh, Twitter will do this when I talk to Twitter, if it's up. And you can also do things, say you had another web service that never goes down, which never happens, but you could use a mock to test what happens when that service goes down. If I force that service to fall down in a mock, what happens to my code? That's a good thing to know. Like, if you're doing payment processing and PayPal's down, what happens? Does your code just explode, or does it just keep trucking and save the data and put it somewhere else? Like, you can do those types of things with unit tests and mocks. Writing files to disk. Disk I/O can be really expensive, and if you're writing tons of files to disk throughout your unit tests, and you don't need to write those files all the time, then you can mock those out. Writing to the database. We all know that databases are slow when you talk to them, unless you're using dev null. I had to fit that in there, I'm sorry. Dev null is web scale. Yeah, so writing to the database can be slow and expensive. So mocking out a database and just stubbing out what it returns can be a useful thing if you have a lot of tests that don't really need to talk to the database, but might need to. When you want to ensure two things are working properly together, if you have two classes and you want to make sure that they talk to each other in the correct way and that the correct methods on your inner object are called by your outer object, you can use a mock to stub out those methods and say, I expect to be called with a 5, I expect to be called with a 404. And if that isn't called with those, if that method isn't called with those parameters, then the test will fail. And when you want to isolate problems, if you want to narrow a problem down to a specific class, you can mock out everything around it, and you'll just be working with that real code. You can stub out everything, test what kind of parameters come out, and it's just easier to manipulate the code to do exactly what you need to do to isolate problems. So say there's a case where this error only occurs when this function returns null, but I can't really get it to return null because of some crazy condition like the file system not being accessible on some other remote system. So you can use a mock to do that. Mocking your code. So mocking out your code is most easily done when you have ways to ensure that dependencies can be swapped out at runtime. And there's 3 primary ways that I use to do this. The first one is through constructor injection. There's factory methods, and there's setter methods. I'm just going to go over each one separately. The examples I'm using are going to be using the PHP unit mocks. So if you haven't used them and you have some questions, just let me know, and I can walk you through how they work. So constructor injection is the traditional dependency injection pattern that all the Java people are like, you must do this. So basically, you accept objects and your object dependencies in your constructors. This lets you construct objects and pass in things into them when they're built. So here we have a car. It takes an engine and a driver. If we wanted to mock out the engine, we could just pass a mock engine in. If we wanted to mock out the driver, we could pass a mock driver in. And that's one way of doing mocks. The next way is for factory, factory, factory. Factory methods can be overridden in subclasses to return mocks. So if you have a race car that has a getEngine method, so let's just say this race car only takes a driver. If we use a mock, we could mock this race car class and stub out the getEngine method to return a different object. That allows us, we can then construct our object, and inside of our object will be a mock. And we'll be able to access that mock and make it do things. Another is a setter method. A lot of frameworks and tools use this. So you have set thing, get thing, set thing, get thing. A lot of times you can just stick mocks into those sets. And that's a really good way to be able to replace things. So if you want to drop off the giant engine and put in a new one, you can use setEngine. So mocks can be critical of a test subject, or they can be a stub of a test subject. Mocks can be used to stub out dangerous components or methods. Critical mocks. So critic mocks check that other objects touch your objects in the correct way. I don't really have a cursor, do I? All right, so here we're getting the mock object and stubbing out its type method. The type method probably does something dangerous. We're setting an expectation that at the first index call, so the first method that gets called, and the method name is going to be type, that we're going to expect it's going to be called with application JSON. And the second time a method gets called on the mock, and the method name is type, we expect it to be called with text XML. So is that kind of clear for everyone, what that's doing? If I don't trip over myself? All right. So then when we run our method on our request handler, we would get some passes or some fails if those methods were called with the correct parameters. This would be in your test case. So in your test case, you would build your request handler object, you'd stub out the response, set some expectations, and then call a method. So probably down here or down here, you'd call a method. I think in this is actually one of the tests from Cake 2. I think this one calls render as, and then it calls render as again. So you'd call render as JSON, which then touches the response object, calls the type method with application type JSON, and if it gets called with something random, the test will fail. Does that answer your question? So stubbing dangerous things. Headers are dangerous. They can make your test suite go somewhere else. That's not very fun. You can also stub out things that talk to expensive services. If there's a web service you integrate with that costs you money every time you use it, talking to it directly inside your test is probably a really, really, really bad idea. So you can use a stub to do that. This basically does the same type of thing as before. We stub out the response property with a cake response object and stub out two methods. We then expect that there will one time be a call to method. The method is status code, and we expect it to be called with a 301. We have a second expectation that header will be called once, and the location, and you'll get two parameters. The first will be the string location. The second parameter is an address. And then down here, there'll be a method, a call to something. I think the call for this is redirect. Excuse me. With too much coffee this morning. With the CakePHP.org location. And the reason you would want to use a mock in this instance is because the object is going to call header. So if you were to run this code without a mock, you would then get sent to CakePHP.org every time you ran this test. That's extremely frustrating and makes it impossible for you to get below that line. So a mock lets you do those types of things and test things that are going to blow up in your face. You can stub expensive stuff. I have to deal with Campaign Monitor. Campaign Monitor is slow, and it falls down. So I have some contact data. Actually, Campaign Monitor is not really that slow. That's mean to say. But it has fallen down on me. So I have some contact data that I'm going to pass to campaign monitor. I'm going to grab a mock campaign monitor service. I'm expecting that one time the get contacts method will be called, and it will return this contact data. This is one of those instances where you're putting a mock inside of another object, and you're using dependency injection to basically put this in, and this service object will then return the value that you told it. So the whole campaign monitor service is stubbed out so that it doesn't actually talk to the external world, and it just automatically returns this value when that method gets called. And you can, does that make sense for everyone? Yeah? One thing about the once method, there's a few of these. There's once, so if the method gets called twice, the test fails. There's another method called never. If the method gets called at all, test fails. There's index ones. You can do expected exactly time, like I think it's called exactly, and you put in a number, and if it gets called more or less than exactly those number of times, the test fails. So it's a good way to test that two objects are working well together. So in conclusion for this section, mocks can help you make tests run faster because you're not talking to external services, you're not talking to things that are expensive, you're not talking to things that are dangerous. And they require less setup and teardown. And what I mean by that is that you don't have to set up another server. If your application has to talk to external servers, you can't really set them up or take them down when you're running your test suite. And they allow you to write true unit tests. So integration tests are important and necessary, but unit tests are often, they run faster and they're a little bit easier to work with because you can control the environment a lot more. And that's the end of the part where I blabber about mocks. I love mock objects so much, so that's why my talk has them. And if you're wondering, Simple Test also has mock objects. They work a little differently than that, and if you look through the core test cases, there's tons of mock objects in them. Automated killer robots. Yeah. This is a test automation for squishy humans. So, automated tests. The whole idea between automated testing is that tests that never run are as good as deleted. If you don't run your tests, just delete them, because they're just going to get in the way, they're just going to start breaking, and they're just going to be useless. So what we can use is we can use build servers. Hudson. Hudson is an amazingly easy to use build server. Hudson is a continuous integration server built in Java. It has a great plugin community. There's about 100 plugins you can install. And it can send emails, it can send Jabber, it can give pithy Chuck Norris quotes, it can do things like run coverage reports and tell you how much of your application is covered by your test suite. It can be configured to run on a schedule, so you can run it every night, every hour, every day. You can have it run on post-commit. You can set up hooks in your SVN repo or in your Git repo that hit Hudson. If you have a Hudson running locally, you can hit Hudson, and then Hudson will run the test suite, check out the code, do any other scripts that need to be run, and run the tests. It integrates with SVN, Git, and CVS. I think it also integrates with Mercurial or Bazaar, so you have no excuse not to use it. A typical Hudson setup that we have at where I work is it runs tests on every commit or push. So every time you commit tests, if people commit in a short window, it'll queue up one job. But every time you run a commit, it runs it on a separate server. It runs all the tests each night in case there was a slow day. So if someone didn't commit someday because there was a meeting or something, then you still want those tests to run. And running tests each night helps you find problems like, oh, it's August 31st. Our code doesn't work on August 31st. We should fix that. Nightly builds are also a good time to run code coverage builds because no one's trying to use the server. And code coverage often takes a long time to run just because it's a very processor-intensive process. So setting Hudson up. I wouldn't try and do it right now because the network's kind of weird, but I did it last night so I can show you. Go to hudsonci.org, right-click on the download link, copy link, wget that address, and then run java jar hudson.war. I've already installed it, so if I can get my terminal to fit in. So I'm going to go into my Hudson directory. Can everyone see that? Go away. All right, so I'm in here, and I just do java-jar hudson.war. And Hudson, unlike many Java programs, does not need a serverless container, does not need Tomcat, does not need 5,000 other dependencies that you have to compile and link all together like some sort of crazy system. You just download the WAR file and run it. When I was writing my talk, I'm like, oh man, this is going to take like 3 hours. I have to install a Java thing. And I don't have Tomcat set up, and I don't have any servlet containers. But that was it. Yeah. I was sadly disappointed that I didn't have to fight Java. So I'm running Hudson right now on my local machine. Hudson runs at localhost 8080. Oh, I can't type. Localhost. Oh, you guys are way smarter than me. Why don't I notice this stuff? Ta-da! So that's Hudson on my machine. So, yeah. So Hudson starts off, we just saw it. You can do new job, you can manage, well, yeah. You can manage Hudson. There's different people that can be in it. You can look at build history, and then basically where the arrow's pointing right now is the project list. And it tells you when the last time the build ran correctly and when the last time the build failed. That's the last failure. And that's how long the test suite took to run. This is an example of what the project test build is. And no, that's not the end. We're actually going to set up Hudson. All right. Since it's local server, we're going to call this test project. And just to show you, it's actually really easy to get Hudson set up. All right. So we're going to build a freestyle software project because we're just going to run some cake shell test suites. Loading, test project. This is going to be cool. All right. It's a Git repo. And we're just going to put in Git. We're going to run some CakePHP tests. I'm going to build a branch that I've been working on. And we're not going to build it periodically. I'm just going to manually build it, but you can run it periodically or pull the source control manager. I'm going to add a build step. I'm going to execute a shell. I'm going to execute cake console. I'm tempting the demo gods today. I'm going to give it a shot. Core, libs, all helpers. So what I'm going to do basically is use the cake test suite console to run all the helpers, all the all helpers test suite for inside the core. I'm going to get it to email me. I'm just going to put in Mark. How's this going to work? Who wants an email? Nobody? All right, I'll send one to Graham. Graham, is it Graham.Weldon? Graham at Graham. All right, we're going to send you an email every time the build fails. Yeah. Ooh, send separate emails to the individuals who broke the build. Nice. So at FreshBooks, we have our build server sitting in our internal Jabber network. So as soon as the build server fails, it's like, Mark broke the build, and it gives it this big output, so everyone knows. It's really, really great because it forces everyone to really not want to break the build, and if you break the build, everybody knows. It sends an email to all the developers and QA people, so everyone's like, you have to fix it, and if you break the build, it's your responsibility to fix it, no matter how long it takes. And you have to stop what you're doing and fix the build. It's awesome. So we're scheduling a build, and it's running. So you can have multiple projects in Hudson as well. You can have as many projects as you feel your server can handle. Well, what Hudson does when it's running a build is it checks out the repo locally, runs the commands that you tell it to run. So you know how we saw, we put in that cake test suite, but you could run a whole bunch of other commands before that. And how it determines the success or the failure of the build is the last console command that runs. It checks the exit status. And if that exit status is a failure, build fails. If the exit status is a pass, build passes. Yeah, let's just see what this thing's doing. Not determined, started. Let's look at the console output. And it is cloning from GitHub. This might take a while. Yeah. Yeah, let's do that. This is going to fail. Let's just cancel the build. Go away. Oh, build failed. We go back to our dashboard. Oh, the build failed. Last failure 1 minute. Graham should probably get an email soon. We're going to configure the project. We're just going to do is it like, does that work? Oh.
Just the directory itself.
Just the directory?
Yep.
I've never done it with different directories. Graham says it'll work, so. Let's see what Hudson's doing. If the internet was working, it would have been a lot more exciting. Oh! Could not fetch origin. Origin could be unavailable. Oh, build fail. That's no good. So, if we had network, do we have network? Very slow. Oh, I don't have a network connection. Shouldn't have tempted the demo gods. We've incurred their wrath. So, what would have normally happened is I would have gotten a blue light. Blue light means that the build is correct. So if it had worked correctly, it would have worked. So basically in the console output, you'd see the results of the test case running, and then the result at the end of what the test case did, and then the build would pass. And so that's how you can kind of set up automated robots to do a lot of your work for you. I can't seem to get an internet connection. So yeah, it's not going to work so great. But did you get any emails, Graham?
I'll let you know.
Shucks. So that's actually the end of my project, my presentation. It's nothing to do with my project. Yeah. I don't know if anyone has any questions. Do I have time for questions? Yeah. Any questions, anyone? Yep. How does Selenium fit into the Hudson picture was the question. Selenium does and doesn't fit into Hudson. So what you can do is you can use PHP unit to run your Selenium scripts. So if you have basically Selenium, it runs through a browser. So you'll need something called Selenium RC and a VM server running. So it's actually kind of complicated to set up. So you can use PHP unit to fire off your Selenium scripts on your Selenium RC server. And then PHP unit will check the results of the Selenium scripts. So basically it goes like your Hudson runs PHP unit runs Selenium, Selenium talks to the browser, and then it all comes back, and then PHP unit says it passed or it failed. And that's kind of how it works. Does that explain your question? Okay. What part doesn't work? It works. It's just that it's a complicated thing to have set up, so if you don't have the infrastructure set up, at wherever your environment is. That's all. It just has a few extra dependencies, like having an RC server and being able to manually boot up VMs and that kind of thing. Yep. Hudson doesn't really care what unit testing framework you do. It works with simple test as well. It just checks the output of the console. What actually passed or what actually failed. Yeah, if you go into Hudson, you can see that console output. And as long as your unit tester pukes out the errors into the console, you'll be able to see what went wrong and why that build is failing. Does that answer? Okay. Yeah, if there's no other questions, then yeah. Yep, at the back. Not yet. That's not yet technically possible. Yeah, probably. With the mind reading device, yeah. We'll just be able to plug your brain in and it'll convert your requirements into tests and write all the code for you, so how could it possibly go wrong? Nothing could go wrong with that. All right. Thanks, everyone.